I want to welcome you today. I'm Martha Russell with MediaX, and I'd like to start today's seminar with a word of appreciation to MediaX members and sponsors whose funds, their contributions to MediaX, have allowed us to support the interactive media and games seminars this series, this quarter, and we intend to next quarter as well. But a very special appreciation to the folks who have identified the speakers, provided the thought leadership, and have taken the initiative to put this new course on the books at Stanford, bringing together a group of people who are interested in not only the science, the engineering, the human sciences of games and how they come together. Ingmar Reidel-Cruz, Henry Lowood, Sebastian, Paul. It's a great group of people, and they have been working very hard on your behalf to identify and bring together wonderful speakers. Two announcements I want to make. One is that on April 16th, the MediaX 2015 conference will take place. And online at mediax.stanford.edu under events, you can go to that conference and register to attend. The theme this year is relevant to what we're talking about in interactive media and games. It is writing the code for personal relevance. We're going to take an interdisciplinary tour through nature's code and neuroscience, through to game code, and as our final speaker for the day, we have Lee Zlotov, who is the creator and writer for the MacGyver series, which you may have seen for many years online. And he is doing some new things now, has a new company that he's launching that is making applications that will allow people to personalize narratives. These narratives may in fact be in games. So I want to encourage you to attend that event and draw your attention to another event on April 20th, which is oriented to creating learning experiences to promote engagement. And certainly games are a part of this. And this is sponsored by the Tekes organization in Finland in conjunction with H-STAR Institute, Human Sciences and Technology Advanced Research Institute. With that, April 16th, April 20th, Ingmar.
Okay, welcome everyone. So I also want to express my gratitude to Martha and MediaX, kind of really helping getting all of this together, as well as my esteemed colleagues who helped organizing. As said, we will keep running this next quarter with another exciting set of speakers. We also have a bunch of activities planned that go beyond the seminars here, so we really want to establish something at Stanford that really brings games and interactive media together. And so if any of you have interest in participating, organizing, or just passively participating, contact us, right? So there are various ways. You're very welcome. Now it's my pleasure to introduce today's speaker, Chaim Gingold. So Chaim has a master's in digital media from Georgia Tech, and he has a very interesting career path in that he participated in some very significant games. For example, as the title of his talk already indicates, working with Will Wright at Spore, but also releasing soon his own game, Earthprimer. He is a game consultant, is an independent game designer, but he also is working right now in his Ph.D. in UC Santa Cruz. And so I think this exemplifies also a general trend that we see, namely that many kind of people making significant contributions in the space of gaming are actually now also getting in academia and getting degrees and making game studies something that gets more appreciated by the academia and really becomes a field on its own. And so without saying anything more, welcome, Chaim.
I'm going to say a little bit more about my background to sort of give some context. So I'm going to be talking about today. So I worked on Spore. It came out in 2008. I was the lead designer for the creature creator and the different editors in the game, and did a bunch of things on that project. But I'm going to touch on that in this project, but not talk about it very much. And then after leaving EA, I then worked as an independent game designer for a few years, where I started the Earthprimer project that just came out last month. I'll be showing you during this talk. And then in that time, I went back to school and started a Ph.D. at UC Santa Cruz. And I'm now finishing that Ph.D. while working at the Communications Design Group in San Francisco. So hopefully that makes sense. Okay, so this is the outline for the talk. So I'm going to talk a bunch about Earthprimer because that's what's hot in my head. It just came out. And then I'm going to talk a little bit about my PhD research and connect it to some themes in Earth Primer and also in Spore. I'm going to talk about my research into play and design, and then talk about SimCity, which is one of the case studies in my research project. So I'm going to first show a demo of Earth Primer, and then I'm going to talk about some design lessons from it. So this is kind of this project sort of bends different genres, and it's a little bit hard to summarize and sum up. So what I'm going to do first is just show the trailer for the project, which I worked very hard on trying to get a sort of coherent narrative to explain what it is. And so we'll begin with that. OK, so that's the trailer. I'm now going to do a demo, and this is I gave this demo last week at GDC, and I worked with the composer who wrote the music and did the sound design. Cliff Carruthers was doing the demo while I talked, so hopefully I can do both of our parts simultaneously without getting too confused. OK, so now we're not on the iPad. I'm using my fingers. OK, so the Earth Primer is structured like a book, and it has 5 different chapters. So we see here the first chapter is about the Earth's interior. These different labels refer to different sections of the project. So you see here different pages. So there's different pages inside of these different areas. So I'm going to look first at this page about volcanoes. So what we have is this pairing between simulations and text, and here we're being prompted to make some magma and make some volcanoes. Okay, so that's kind of the basic. So these pages have simulations and words on them. And so let's look at some of the other chapters. The next chapter is about the Earth's surface, and you get to play with things like mountains and sand dunes and erosion. And then there's a chapter about the water cycle. And what I'm going to do is I'm going to show you a page about rain shadows. So what's going on here is there's this is not a canned video. It's a simulation that's comprised of many different layers. You can see a few of them in here. There's precipitation layer. You can see there's humidity. There's temperature. And we can also show the wind on here. And all these, so there's all the different processes are being simulated in real time. And we're looking at just a few of them here on this particular page. And what this page is illustrating is it's illustrating rain shadows, which is, you see here on the left, the water is evaporating up out of the ocean. It's being blown inland. And then it's being stopped by these mountains. And the air is forced up, and the water is squeezed out of the air. And it rains, and so the far side of the mountains, it's dry. Okay. So what we can do is we can use the lower bedrock tool we have here, and we'll see what happens if we remove the mountain range. What we see is that now the desert is gone, or it's mitigated. Right now more moisture can reach farther inland. So that's the basic pattern of the project, the book. And as you progress, you unlock more tools. And on the next page, there's a satellite photograph that shows the same phenomena. So we're sort of combining doing and showing and telling all together. Yeah, so as you progress, you unlock more chapters and more pages, and ultimately you land in the sandbox chapter where you get all the different tools that you've unlocked and learned about throughout progressing through the thing. So here's the sandbox, and at this point now you have all the tools available to you, and we can do different things. Like we can lower and raise the sea level. We can use the sun tool, and we can change the temperature of the whole map. We can freeze everything. Oops, that's heating everything up. Make a bunch of ice. And we can also we can make some mountains. We can change the size of our brush that we're going to work with, and raise the. We could just get rid of the ocean completely. Now it's totally dry. Okay, so that's what it's like to actually play Earth Primer. So what Earth Primer does is it combines different tropes from games and toys and simulations into this thing, which doesn't really fit into any genre neatly. And it's kind of like some other things that are out there that are also sort of trying to combine things in unique ways. Another example would be Parable of the Polygons, which if you haven't seen it, I highly recommend you check it out. It's a really cool interactive web page about how segregation works. And these are exploring the theme of learning through play, through experiential engagement. And the way I think about it is inventing a new genre is, when the printing press was developed, we didn't, things like the novel and cookbooks and so on didn't come about right away. Those are media forms that had to be invented and designed. And so something like Earth Primer and Parable of the Polygons are sort of experiments that are sort of trying to sort of collaboratively invent new genres, new design patterns for other designers to copy and steal from. So that's one of the reasons that I made this project. Another one is that I really love making and playing with simulations, and it's what drew me to Spore, or drew me to this project. And in developing this genre, what I wanted to do was develop a framework for building a completed experience that was comprised of simulations. So, and not forcing the simulations to live within a game that has certain conventions about conflict and progress and so on. So my hope is that other designers come and steal from Earth Primer and basically take it, sort of take whatever they can from it, right, to make new things. And when I say steal from it, sort of take some of the design ideas that are in there. So this is available right now. You can check out the website, earthprimer.com. You can download it for your iPad right now. So since releasing it, I've had a lot of people contact me and sharing their enthusiasm for the project and wanting to talk to me about it and learn more about, basically they wanting to copy from it in some way. And so the next question is, what should you steal from this project if you're going to steal from it, right? What should you copy? Should you make another geology thing? Well, that maybe you could. And that brings us to the next section of this talk, which I'm going to in an attempt to respond to these requests, I'm going to share 10 design principles or guiding design principles and design lessons from doing this project. Okay, so number one, Earth Primer is an example of teaching or learning that combines telling and showing and doing. It isn't someone telling you about a topic or someone showing it to you. It's a system that you interact with. So it's all about experiential learning, engagement. Another guiding design principle is to share enthusiasm for a topic. And Seymour Papert, who's a seminal philosopher and designer in digital learning environments, he wrote this really wonderful book called Mindstorms and developed the Logo programming language. He wrote that teachers who are fearful of mathematics do a disservice to their students, because what they do is they perpetuate that fear. And what the best teachers do is they are sharing their enthusiasm and love for a particular topic. So when a geologist or mathematician or historian is doing geology or history or mathematics, they see things that are not apparent to those of us who are not experts in those fields. And so you might be passionate about the very specialized thing you're doing. And I think that what something like this project does is it attempts to transform something which is normally sort of like a private love for a topic, right, and help make it more accessible, right? So if a geologist looks and sees the mountains around them, they are seeing things that we don't see, right, because we're not experts in those domains. So I think that these kind of experiential learning systems can sort of help us share that enthusiasm. So and I contrast this with the sort of sugarcoating mode of teaching, which is to take something that you believe is dry or uninteresting and then try to like dress it up like you should find this interesting, right? So but it kind of tastes bad. It's like broccoli. I'm going to put chocolate on it or something. So for me, it's really about finding the essence of what makes something interesting and sharing that. Another key point is to think first and foremost about experience and to design in terms of experience. So usability is part of experience design, but when I talk about design experience, I'm also thinking about things like designing for a sense of delight, for a sense of wonder, for a sense of curiosity and surprise, and to think in terms of the sort of overall arc of an experience that you're producing, right, that's from beginning to middle to end. And to think about the pacing, sort of the speed at which you pull people through, the way that you stop, the way that you sort of subtly encourage people to continue, right, and arouse their curiosity to move through something. And obviously, this is a complicated and deep craft, but I'm just gonna sort of hint at it here. Part of it is also producing things that are sort of have a lot of rich feedback, that have a lot of rich visual, auditory, and tactile experience as part of them. Games are, in my opinion, the best examples of experiential software design. Video games are all about, or computer software that are designed in terms of experience very, very carefully. And while I think that Earth Primer is not a game, and I don't think that what it's doing is borrowing from games as much as games are drawing from a deep well of craft knowledge about experience design that Earth Primer is also drawing from. So I'll return to this point later, but I want to contrast it with the idea of sort of gamification, which is the idea of sort of taking tropes, game design tropes from games and applying them to some other topic, which sort of copies the sort of superficial characteristics of games and uses them instrumentally for some other purpose, and compare that with something else, which is to look at the fundamental experiences that make games fun, and playful, and engaging, and use that. Another key point is that I try not to lecture in the project. So in this video loop, what we see is at the beginning there's a text, there's a prompt that says, "Can you make an island?" Just one sentence, question mark, and then it waits for the user to make the magma and create the volcano. And then after the system has seen that that's done, then more text comes in. So, and I'm contrasting this with an earlier incarnation of the project where there was you'd come to like a wall of text and then a simulation, and the text would never respond, and you would do something, and the text never acknowledged that you did it. So there's this sense of, it's not just this thing talking at you, but it sort of tells you, it asks you to do something, and then it's listening to you, right? It says, "Oh, you did that. Okay, now I'm gonna respond to that." So there's this feedback loop within each page. Another design technique that I use in this project is to account for multiple different modes of engagement. So there are some people who will approach a project like this or a page, and they'll want to just read everything first and sort of make sure they understand exactly what's going on before they go and they poke and play. Other people, and I think about this as the sort of 2-year-old factor, other people just want to come in and just poke at it and just play. And it might be that it's different people. It might be there's the same person engaging at different moments in time in different moods. So what I wanted to do is make sure that the experience was enjoyable regardless of whether or not you are the kind of person or in the kind of mood where you just kind of want to poke and play and you don't even care what it's about. You just want to have a satisfying tactile finger painting experience. And maybe that's then what draws you then into the text, into some of the informational content, right? On the other hand, maybe you're the kind of person that just wants to read first. So what I try to do is account for this sort of more cautious and more playful modes of engagement. And what's interesting is that I've gotten reports from people who are playing Earth Primer, and they said they play with their kids. So there might be like a 4-year-old who might be too young to actually really understand the concepts of the text, but they might play with an adult together, which this to me is very interesting. Very interesting design space to think about is sort of how you can create things that are sort of collaborative for different kinds of players, different kinds of engagement. And I would compare this to something like David Macaulay's The Way Things Work, which his work is a huge influence on this project. And in this Japanese version of a page from The Way Things Work, you see that there's there are these images and there's this text, and you can enter the page either through the imagery, right, just kind of get enveloped into this environment or into these things that are happening, or you could enter the text, or you could enter the page through the words first, if you're a Japanese speaker. You could enter it there and sort of read and then go to the pictures to flesh it out. So it doesn't force you to explore each page in a linear order. It invites you to go in, however you feel. Another key design challenge with this project, this is a big challenge, was finding the right amount of balance to guide play through the project. So initially, the pages were a lot more freeform. You could go into a page and basically do whatever you wanted to, just kind of muck around. And there was that wall of text effect, and there wasn't a lot of feedback. And that was too open for people. People would get lost and confused. But at the same time, I really liked that ability to just go into a page and kind of zone out, or be a 2-year-old or whatever, and just kind of poke and play. So what I try to do is find this balance between guidedness and openness and closedness, right, or direction and openness. And this happens both globally at the scale of the entire book, where you sort of advance from page to page to page to page, and each chapter unlocks, and a page unlocks, and you get these tools that unlock at the end. So there's this structure that takes you through the entire project. And it also happens locally within each page. There's a little bit of structure that gives you a little prompt and asks you to do something, and then you do it, and then you return to the text. So there's these things that kind of pull you through, these calls to action. And then it ends, with the sandbox. That's the sort of finale of the arc of the experience, is that you've played through this thing, and then you have this sandbox with all the tools available to you. And now you actually can appreciate them and enjoy them because you know what to make of them. Another key to design principle of this project is to really harness the computational power of the computer, and not just to sort of show videos or pictures or text, but actually to simulate things, bring things to life. I worked really hard to get it running on the iPad 2. That was the baseline machine, and I think that's something that we really can take advantage of with this kind of technology. We can use the power of computation to bring systems to life, right? And then once we brought those things to life, we then want to touch and engage with them. So sort of the focus on sort of tactile engagement is a big design consideration of this project. This illustration is made by Phil Fish, who's the creator of Fez, for the cover of this by Steve Swink's game Fieldbook. And I think it does a nice job of suggesting the kind of phantom touch and feel effects we get when we play games, right? That there's a kind of, you're not really touching or anything concrete, but when you interact with a well-crafted game or digital toy, you get this sort of phantom sensation of tactility. And in the particular case of Earth Primer, I'm taking a system that might otherwise be invisible, right, what's abstract, and making it very concrete and tactile, right? So you can paint with wind and make sand dunes, right? And it feels like you're sort of running your hand over the environment. The ninth point is about segmentation, which is a really key concern for designers, especially digital media designers, and is to think about how you're going to segment your experience or your content or your material into smaller pieces. And this is something that I'm very pleased with how it turned out. So at the beginning of the project, there's this 2D simulation with the tectonics and the volcanoes, which we saw in the beginning of the demo. There's one simulation, just indicated by that red circle at the top, that's used as a template for different pages, right? So I'm kind of like stamping out multiple pages from this same core simulation. And then there's also one simulation, which I didn't show you, which is just a little interactive Pangea diagram, where you can just slide the slider through time. And that's a simulation that just appears only on one page. And then there's the 3D sim, which is used throughout the book, then it's also used in the sandbox mode. So there's these simulation templates that are sort of reused across different pages. And there's a kind of separation, the segmentation that's happening, as well as a reuse. And this seems like such an obvious idea, And it is, but it's just a powerful idea that I want emphasized. That I want to emphasize it because it allows one to repurpose and parameterize and reuse the content or the simulations. But it's also very liberating for a designer because it means that you don't have to make one system that does or everything coexists together. You can make different systems and kind of make these one-off systems, right? And then put them together into a finished experience that takes you all the way through. So this segmentation into these different, stamping out these simulation masters, these different pages, allows for continuity, but also the separateness that allows me to just say, oh, I'm going to invent a new simulation that's only going to live on one page, right? And which is counter to the way that simulations in games normally works, where you have like one simulation that is SimCity or SimEarth or whatever. So it's very liberating, right? And it'll help solve some of the complexity that you end up with when you build complex simulations. The final point I want to make about this is going to be the least specific, and it's going to say that there's just a kind of sense of playfulness that I wanted to capture in this project and make it a playful experience, like in the tagline that I have in the beginning of the video that says it's a science book for playful people, right? So it's not saying it's for children or it's for, yeah, or for, it's like for people that are interested in science and are playful. And like I hinted at earlier, I believe there's this deep well of experience that we draw upon, game designers draw upon when we make games, and it's to think about aesthetics of wonder and delight and surprise. And to me, these are experiences that are they're about playfulness, and I'm interested in what it means to design playfully, which takes us to the next part of this talk, which is about play design, which is part of what my PhD research is about. But before I talk about play design, I need to first back up and talk about game design a bit, and contrast and compare play design to game design. So game studies, which is the academic study of games, and game design, which is this practical field of game crafting, are both, in their modern incarnations, are both constituted by the same underlying commitments. And the basic commitment that these practices share is that there are certain formal, universal structural qualities of games, right? So an influential contemporary exponent of this idea is Jesper Juul, and this diagram is from a 2003 paper of his. And what Juul does is he synthesizes a lot of the different definitional thinking around games, and argues that there are these, 6 different qualities. And in the middle of the circle, we have things that are strict games, like Pac-Man, baseball, Halo. And what he does is, then there are these things that are more peripheral, and that arcology thing is SimCity, see open-ended simulations, and that's at the boundary because it doesn't valorize outcome. It doesn't give you a winning or a losing condition, right? And so he compares things that are games, things that are not games, like sitting in traffic, right, or playing with hypertext fiction. And so there's a center, and then there's the margins, and SimCity sits sort of uncomfortably at the border. It's like, something about it is game-like, but it also is not game-like. And I want to stress that this set of ideas that are sort of crystallized or that are reproduced here are shared amongst game studies folks as well as game designers, practitioners, and teachers of game design. If you look at these influential textbooks, Rules of Play and the Game Design Workshop, they both which are made by practicing game designers and are influential both in game studies and in the game industry, they're both highly committed to this set of ideas. And the beautiful thing about this idea is that it links up board games, things like sports, and things like video games, which on the surface would seem to be completely, radically different kinds of things and experiences, and it identifies a common thread through them. So this is what allows that to work. However, there are limitations to this approach, and one example of that is the fact that SimCity is sort of stuck at the periphery of this framework. So we can't really use all of our game studies and game design tools to think about SimCity. So and in fact, Maxis and Will Wright have called SimCity a software toy. And so the question that I ask is, what kind of framework will put SimCity at the center instead of at the margins of a discourse of design and study? Right? What if playthings and playgrounds and playmates were actually the center rather than the periphery? And this is really the core motivating idea behind thinking about play design, to identify different set of phenomena, to say that these are the center. What are the things that they have in common? What are the common questions and concerns that scholars and designers have about these different things? So I'm not gonna get too much into this because it's a whole interesting maze of material. But I will say that some of the things that we would want to get out of this kind of framework would be, what is that deep well of experience that we draw from when we are drawing from when we were making playful things as well as games, right? What creates the aesthetics of wonder and delight and surprise? What does it mean to design something that is going to be playful? And then a really important question is, how can you define play in a way that's useful for designers, that doesn't fall into this, the sort of the trap of all of the ambiguities and contradictions that come about when you try to define play and pin it down? Are there shared design considerations that things like toys and playgrounds and SimCity have in common? Are there shared aesthetic considerations? And then there's really concrete things, like how do you create a sense of safety and a sense of invitation to engage with something, right? Playfully. And one way that I approach this question is to think in terms of scaffolding, which is to think about the ways that an experience, or to think about the ways that a playground or a toy or a cultural practice might scaffold playful attitudes and experiences and interactions. Okay, so how am I going about doing this project? And this play design research project, the big answer is through case studies, and in particular one big central case study, which is about SimCity, which is the liminal artifact that I mentioned earlier. So what I'm doing, a large part of my research is about undertaking a very detailed case study of SimCity and the programs and simulations and ideas that came before it. And I'm interested in a few high-level questions, like what makes SimCity compelling, what makes the aesthetics of SimCity work, and where do those things come from, and how can those things be traced to the code of SimCity? And in particular, SimCity is a good target because it's liminal. It doesn't fit into that game design, game studies framework neatly. It's a very evocative work. It's a very influential object to think with. Ian Bogost just published a piece about it that touches on it very heavily in The Atlantic. And SimCity appears over and over again in discussions about play and games and learning and simulation. It's like this really naughty thing that just keeps, it's like this really philosophically provocative object. Another reason to pick SimCity is that it's an open source project now. At least the original SimCity has been open source for the One Laptop Per Child project. So we have the original code available to us to study, which is especially important in the case of a simulation game because you don't really know what's going on under the hood, right? It's all about artifice and making you believe and see something that's there that's not really there. So to actually be able to look inside and see what's actually going on is really critical. It's a seminal game. This is the game that really launched the whole line of Sim Maxis titles like Sim Earth and The Sims and Sim Ant, right? And it's had a deep effect upon the whole game industry. And another thing is that Will Wright, as a designer, draws upon many different sources. So there's a very rich genealogy of influences to explore in this particular title. So if we're going to, so to talk about SimCity, though, we have to talk about software, right? Because it's a piece of software. And it raises the question of what does it mean to think about a piece of software. So I put up this quote by Seymour Papert. And this quote actually comes from, he was responding to criticism to logo, where some education researchers were doing this very quantitative analysis of the efficacy of logo as an educational tool. And he was really pissed off by what they had to say. And so he wrote this really interesting essay where he argues for something he called computer criticism. And I'll just read this. He says, I am proposing a genre of writing one could call computer criticism by analogy with such disciplines as literary criticism and social criticism. The computer is a medium of human expression. And if it has not yet had its Shakespeare's, its Michelangelo's, or its Einstein's, it will. We have scarcely begun to grasp its human and social implications. So he doesn't explain how to go about doing this, but he poses this question: what would it mean to look at software and computers as a humanist would? And then the question that then I wonder is, well, what is software anyways, right? Like and can we define software in a way that foregrounds its cultural and historical and social qualities, that would allow us to look at software through a humanistic lens. And so I found this really satisfying answer in the work of the historian Mahoney. I'm forgetting his first name right now. And and this is a diagram from this 2005 paper on the histories of computing. And what Mahoney's doing is he contrasts the traditional ways in which computer history is done, which is very machine-centric, to say like, well, the ENIAC was invented, and then there was the EDVAC, right? And we had this other set of hardware, and these particular machines, maybe we can look at these machines, came from particular organizations that were trying to solve specific problems, and then out of that we get certain fields, right, like computer science and so on. And he changes the emphasis, and he argues for this other model of computer history, which puts the emphasis on the communities of computing, right? So putting the focus really on the cultural and social practices around computers, and argues that actually all the particular applications that we put computers to predate the computer, right? And they actually are simply that these particular purposes people have in using computing machines are simply adopting the computer into their own practices and then producing the software and hardware that we know. So a specific example that he doesn't use, but I'll use because it's about games, is a Japanese playing card manufacturer that was founded in 1889 called Nintendo. And Nintendo means leave luck to heaven. And after World War II, Nintendo was tinkering with toys and novelties. They took up electronics and computers. And they basically extended their own playful history with early computer technology and electronic technology. And ultimately, created this Game & Watch series and the electronic love tester, and ultimately the NES. So this is a very specific example of this. Here's a practice that predates the computer, right? This is this company that makes games and toys, and they encounter the computing technology, and they just take it into their own practice and move on with it. And Mahoney makes this really interesting observation that the computer is an abstract symbol processing machine. He's not the first person to point that out, of course. This illustration is from a 1955 Scientific American article, and this is a representation of a Turing machine, which I really like. And Mahoney points out that there is this notion in computer science of the abstract symbol processing machine. The Turing machine is one common form of it. And that this computer, this abstract Turing machine, can be any other machine, right? It is the computer. And software is the thing that gives shape to this computer and makes it into a specific kind of computing thing that does a particular thing for a particular community. So we have the abstract machine that is then adapted and transformed into the needs of a specific community. And it is software that does that work. Software is the thing that takes the abstract computer and turns it into a specific kind of thing, whether it's an ATM or an electronic toothbrush, Facebook, Google, SimCity, a robot, right, or a war machine. So it's software that's doing this work of transforming and specializing. And it's by looking at software that we can really get at, and this is a sense of software that is really oriented around the social practice, around the communities that are engaged with computing. And then he offers that design is if we think about the design of software, we're thinking about how these machines are adapted into specific purposes. So I like this because this gives us a sense of the software as an object for a humanist study. And then I'll end with this section with this quote from Alan Kay, where he sums up this idea, very succinctly: "It is software that gives form and purpose to a programmable machine, much as a sculptor shapes clay." Okay, so back to SimCity. So SimCity is, if you haven't played it, this is the original SimCity from the Mac. It's this simulation game where you are put in the role of some kind of super powerful city planner, and you create different zones and you lay in different infrastructure, and then in those zones different buildings spring to life. And there's this sort of inner logic that is partially exposed to you but not fully exposed to you, that guides when things build, how things move in, how your city develops. You can see, I don't know if I can point, but you see that C with the white box, the C in it, that's an unbuilt commercial zone. So the city planner, the player of this game, is hoping most likely that someone will move into that commercial zone, right? And to the right of you, we can see this low density residential housing. And a really key part of this whole system is this RCI meter down here. And if you've played SimCity, you know that what that meter is doing, what those meters do is they tell you, they coach you as to what the city wants. It gives you insight into this opaque system. So right now we see that the city really would like more residential and commercial zones. And sometimes those things go negative if there's too many of them. So that's the system sort of giving you feedback as a whole about what the city, what this living simulated thing is desiring. and it's orchestrating the action for the whole city. So if we look at the code, we can see behind into the we can look into the logic that's driving this. And what I've done here is is I've produced some figures from reading the original source code to the project. And Willwright has said that Jay Forrester's system dynamics, which I'm going to talk about now, is an influence on this project. We can also look at Will's comments. And if we look at the code, which I've put the code for a particular function called set valves on the right, and that's the code that appears in the original game, or one particular version of the original game. And at the left, there's a figure. What I've done is I've taken that code and I've restructured it as a kind of diagram that explains the logic of this. And we're not going to go through this in detail, but you can see things like births and migrations and employment in the lower section. And what this is doing is this is governing the sort of the global flow of population in the city, and it's correlating these qualities such as the amount of people living in the city and the amount of industry in the city, and it's deciding whether people should move in or move out, how many people are unemployed. And this particular idea comes from Jay Forrester's work with urban dynamics. And this work was done in 1969. It was published. And Will took this and adapted this idea into SimCity. And this particular idea, the system dynamics idea that Forrester worked with, has a very interesting history, which I'm going to just sketch very briefly here. But basically, Forrester began his career at MIT in the 40s working with servo mechanisms. And then he was the project leader for this computer, this seminal computer called Whirlwind. And after finishing the Whirlwind project, which was very, very expensive and took a long time, he was recruited into the MIT Sloan School of Management. So he went from being an engineer into this management school. And in particular, and he writes that the school was founded at MIT specifically because people were interested in what a management school looked like in a very technical institution. And it was expected that Forrester would do something like information systems or something like that. But he wasn't that interested in that. And what he did instead was start to think about modeling industries through digital simulation. And in his early work, he looks at sort of the supply chain. What happened is that I think some managers, I think from General Motors, were pointing out that there was this fluctuation in their orders that they couldn't explain. They thought there was a seasonal change in their orders, and Forrester built a model and said, actually, no, we can explain all that fluctuation endogenously is a result of simply the organization of the system itself. So just looking at the feedback loops, he said that was sufficient to give us these, those waves. And then he starts to abstract from this specific economic model, this business model, into larger phenomena. And ultimately, that takes him into cities. And the way that he gets into cities is that there was the former mayor of Boston was taking an appointment at MIT, and then he'd had polio as a child, and so he used a cane. And Forrester happened to have a ground floor office, and so the office next to him was vacant. So he ended up randomly next to this mayor, and they started talking about the city and the problems of cities. And this is during the urban crisis of the 60s in the United States. And so there was a lot of interest in this. So Forrester basically says something like, as he heard Mayor Collins talk about the problems he was facing, he recognized the systemic structures he'd already been thinking about. So he's basically taking this template that he'd been working with for many years and just sort of mapped it onto this problem of cities. And my claim is that the part of the aesthetic of SimCity is this kind of oscillating, fluctuating, unpredictable sort of bounce in the desires and growth of the city. And in fact, that sort of surprise and delight that comes from that is directly attributable to the system dynamics technique that's being used. And not only did Willwright get a sort of mathematical computational framework for modeling social systems on the computer from Forrester's work, but he also got the sort of these instabilities and sort of the general perspective of sort of artfully and aggressively abstracting from the world into a computer model. And it also has the effect of giving a kind of overview of the model to the player as well. So that's that's the talk that I've got. So just to summarize, I've shown you Earth Primer and talked to you a bit about some of the design thinking behind that project. That took us into some questions about what it means to design playfully. And we talked a little bit about play design and game studies. Then we talked a bit about SimCity and how I'm using SimCity as a case study for thinking about playful design and looking at SimCity as a simultaneously as a technical and cultural artifact. Yeah, that's what I've got. You can check out Earth Primer. There's the website. Yeah, thanks.